Today we talk about our third and final type of transformation. We've covered translating, we've covered stretching, now we're going to talk about reflecting functions. So, to the right, I have an example of taking a point, so taking this point P right here, and then reflecting it over the x-axis. Okay? So, in reflecting it over the x-axis, what do you notice happened? So here the x value stayed the same, but notice the y coordinate. So when you flip it over the x, the point is the x is staying consistent, okay? It's staying exactly the same along the x-axis, but the y coordinate became negative. So that's what happens when you do those types of reflections, okay? So if you're reflecting over the x, the y actually flips its sign while the x stays the same. And that actually holds true when you do this with entire equations as well. So if I'm trying to reflect the function y equals negative 2x plus 5 over the x-axis, what ends up happening is the y becomes negative, just like it did with the point from the first one. Okay, now, when looking at this, that doesn't look very nice to me. Okay, so what you actually end up having to do is divide everything by -1 to get that. Okay, because you always need y by itself. So if you have to put in a negative to the y, I do want you to resolve that for me. Okay, solve it so y is always by itself. Now, I do just want to show you really quickly, graphically, what happens. So this, I'm going to graph in black. So starting up at 5, slope of -2, down 2 over 1. So remembering all of those beautiful graphing skills we spent time covering. And this one I will graph in red. This time starting down at -5, slope of +2. And hopefully you can see that truly is a reflection across or over the x-axis. Okay, you can see how that played out. So, what about the y-axis reflection? So here's an example. I have this point A, and I'm reflecting it over the y-axis. So this time, notice the y value stayed the same. A y-axis reflection holds its y value. But then the other value, the x, notice what happened. Just like before, that opposite one becomes negative. So here a y-axis reflection results in the y value becoming negative. So for a reflection, x-axis reflection, the x holds on to its value, the y has to flip. Same thing with the y-axis reflection. There the y holds its value and the x has to flip. So let's do an example of that. So here, y equals -4x minus 9. A y-axis reflection means the x takes on the negative. So here, all that means is that would become a positive 4x because a -4 times a negative x, those negatives are going to become positive. And again, let's just really quickly see what that looks like graphically. So let's graph that. So we start down at -9 and then slope of -4. Down 4 over 1. Well, I can't really go down 4 over 1, so I'm instead going to go up 4, back 1. Up 4, 1, 2, 3. Oh, sorry. This graph is so tiny I got mixed up on my point. 2, 3, 4, back 1. 1, 2, 3, 4, back 1. And now let's do this one. Still starting at that -9, but this time going up 4 over 1, up 4 over 1. And you can see what it looks like to be a y-axis reflection. Okay, but again, just note, whichever axis you're reflecting over, that is the variable that keeps its value. The other one takes on a negative. So let's just get a little bit more practice on that. Okay, so x-axis reflection. So the x gets to hold its value, okay? The x gets to keep its value, and the y has to take on a negative. When it does, now I have to resolve that. So I have to divide everything by -1 to end up with that. Y-axis. This time the y gets to hold its value while the x has to take on the negative. So here, when I resolve that, -3 times -x will be a positive 3x. And that's what you're going to end up with. We can do the same thing with other functions as well. So here, x-axis reflection, again, the x gets to keep its value, and the y has to take on the negative. When I go to resolve that, divide everything by -1. Y-axis, now the y gets to hold its value, and the x has to take on the negative. Now here, if I square -x, so here's kind of the cool thing is when you square a negative, it actually becomes positive again. So that actually remains a positive x squared minus 4x minus 7. Okay, but again, the big picture here, when you do a reflection, that variable keeps its value. The other one has to take on the negative. All right, so as always, when you're done taking these notes, now you may move on and you can start working on the practice work.